Let's take a look at the solutions to the quiz for section 1.8. And to start off, for this first problem, what we want to do is rewrite this guy as 3 as x to the negative 1. And so we have this, because then we can use the power rule. So the first derivative then, f prime of x, is equal to 4x cubed minus 3x to the negative 2. Now to find the second derivative, we're going to, write the notation, power rule both of them, so we get 12x squared. The negative 2 comes down times the negative 3 to give you positive 6. X to the negative 2 minus 1 is negative 3. You can rewrite that as 6 over x cubed if you want. For this next one, we're going to have here, we need a chain rule. So the first derivative, bring the 4 down, keep what's inside, subtract 1 from the 4, and then chain rule out the derivative of inside, which is negative 2x. You can rewrite that if you want to, and to do that, it can become negative 8x, 3 minus x squared to the third. Now when we take that second derivative, we're going to need product rule, derivative of the first times the second, plus the first, which is minus 8x, times the derivative of the second. So bring the 3 down, 3 minus x squared, 3 minus 2, 1 is 2, and then you're going to chain rule out, and it won't fit, minus 2x. And so you have to use the product rule because here you have the product of two different functions. So you can't, you can multiply this thing out, but it's to a third power, so I wouldn't do that. I would use the chain rule on that. Okay, next guy. For this one, we're given y, and we have to find the second derivative evaluated at negative 1. So let's find the first derivative, negative 12x cubed minus 2. Second derivative, negative 36x squared. The derivative of the 2 is 0. And then now we have to evaluate that thing. And the notation d squared y over dx2 x equals negative 1 is really saying take the second derivative and evaluate it at negative 1. So we get negative 36, put the negative 1 in and square it, which gives you positive 1. So we get negative 36. For the next one, we know that velocity is the derivative of the position function. So velocity is going to equal 15 t squared. We're taking the derivative of this guy, plus 1. We have to evaluate it at 2. So v of 2 is 15 times 2 squared plus 1. So that's 4 times 15 is 60 plus 1 is 61. So the velocity is 61 miles per hour. And then acceleration is the derivative of the velocity function. And we need to evaluate that at 2. So you get 60 mile per hour squared, and that is the acceleration. So interpret your answer with respect to the original problem is that after 2 hours, the car is accelerating, I'm trying to write accelerating at 60 miles per hour squared. So it is going that much faster at that point in time. So that's it. Hope you're having a great day.